Okay, so let's have a look at another question from the 2022 HSC Advanced Maths paper. So this is question 20. We're told a scientist is studying the growth of bacteria. The scientist models the number of bacteria n by the following equation. T is the number of hours after starting the experiment. What is the initial number of bacteria? Alright, so for part A, we've been told the number of bacteria at a certain time is equal to 200 times e to the 0.013 times time. Now if we let time equal 0, this will give us the initial. So this is n of 0 is equal to 200 times e to the 0.013 times 0, which is 0. E to the 0 is 1. This is 200. Therefore the initial number, which we could just call it n of 0, is equal to 200. So there were originally 200 bacteria. Now for part B, we're asked what is the number of bacteria 24 hours after starting the experiment? Well, T is the number of hours, so we just need to evaluate N when T is 24. So N when T is 24 is 200 times e to the 0.013 times 24. This gives us N of 24. We plug this into our calculator. We get 200 times e to the power of 0.013 times 24. That is 273,20939 ... So this is the number. It doesn't tell us how to round it, so we can just leave it in this long form, or you can choose to round it if you want to the nearest number. So this is part B. And now part C. What is the rate of increase in the number of bacteria 24 hours after starting the experiment? Whenever you're asked for rate of change is almost always derivative. So we need dn dt, and we need to evaluate it when t is 24. So if we differentiate this function, the nt function up the top here, we get dn dt is equal to 200 times e to the 0.013t multiplied by the coefficient in the e power, 0.013. We now need to evaluate this. So we need dn dt when t is 24. So this is equal to the number we just found multiplied by 0.013. So 273.230939 times 0.013. My calculator tells me this is 3.5520 ... It doesn't tell us how to round this, so we can just leave it in this form. We can say dn dt when time is 24 is equal to, we might round it to 2 decimal places, 3.55 to 2 decimal places. And this is the answer to part C. Now in terms of the marking is pretty straightforward. We are going to have, for part A, 1 mark for getting 200. For part B, you will get 1 mark for getting the number of bacteria. Now we could also say that this is about a whole number, because this is number of bacteria. We could say this is 273. So you get 1 mark for some working similar to this. And then part C, you'll get a mark for finding or attempting to find the derivative. And then you will also get a mark for finding the rate. Now we've just left this rate in its dn form, but this could also be written as the rate of increase, or you could say the rate of change of the original function, and you could say this is 3.55. This is in terms of bacteria per hour, because this was how the equation was set up. So this is how we do this question, and this is an approximate marking guideline.